Hey, geometry. So today we're going to get into section 7.3 on triangle similarity. We already did similarity on polygons, so we're going to focus in on triangles and how we can know when they're similar. This is kind of similar to our side, side angle, side, things like that. We'll actually see some of those in here, but they're actually referring to proportionality instead of congruence. So postulate 7.1, you can call it that if you want, but the angle-angle similarity postulate, if two angles of one triangle are congruent then to two other angles in another triangle, then the triangles are similar. And so remember, similarity means that all the angles are the same, but the sides are proportional. So all the angles are the same. Well, if I know two side angles in a triangle are the same, I know the third angle is going to be the same. That's the third angle theorem. So essentially we're applying that here. So all we need to know is exactly two angles are congruent, and we know the triangles are similar. So determine whether the triangles are similar. If so, write the similarity statement, explain your reasoning. So here I've got these angles I've got already, 57 and 57, so those are congruent. But I got 48 and 75. Well, that's, may seem like no, but let's double check. Let's figure out what that third side is. So if I do like 48, 180 minus 48 and 57, turns out that third angle is 75. So if this is 75, then that's it. We know that these angles are congruent. I could also do 180 minus those two and realize that this one's going to be 48. So yes, these are similar. And so then if I'm going to write this similarity statement, we could write this triangle JKL is similar to triangle, and I got to get these lined up. So J corresponds to Q, K corresponds to P, and L corresponds to M. Those are the congruent angles. The next one, nothing marked, but we do have the parallel. So, there's a few different ways we could go about this, but for one, I got vertical angles. So there's one pair of congruent angles. And then with these parallel lines, I could treat that as a transversal. We can mark those as congruent. And then finally, we can mark these as congruent, W and R, if we wanted to, not necessary. So we can go ahead and make so these are similar, we can make our similarity statement. Notice they're not the same size, they have the same angles. So we can do triangle, and then I'll start with R, I guess. RSX is similar to triangle, and then R corresponds to W, S corresponds to S, and X corresponds to T. All right, so that's one way of showing that we have similar triangles with just angles. The other ways, we could use sides. So we actually have to show that sides are proportional. So if the corresponding side lengths of two triangles are proportional, then the triangles are similar. The triangles are similar. So for instance, in this case, if these sides are proportional, we could say JLK is triangle JLK is proportional to triangle MQP. Another way we can do this is, and so actually let me write this out to make sure we're cool with this. So JL over MQ should be equal to LK. I'm doing like left triangle to right triangle over QP, and then JK over MP. If all of those proportions are the same, then we know that they are similar. So we can also do this with two sides and an angle, and that's enough to know that they are similar. So if the lengths of two sides of one triangle are proportional to the lengths of the two corresponding sides of the other triangle, and the included, the angle in between those two lengths are congruent, then the triangles are similar. So in this case, if I know that RS over YX is the same as ST over YZ, as well as if we know that, and if we know angle S is congruent to angle Y, then we know that they are similar. So then similar. All right, so applying that, we've got a bunch of sides here. We could also show an angle here, but we'll leave that out. Got a bunch of sides, so I'm going to go top triangle to bottom triangle and put the kind of corresponding parts together. So I'll start with the 6. The corresponding side to 6 is 5. So 15. 6 over 15, is that the same fraction as 5 over 12? Right, this thing has been like kind of rotated around and down there. 5 over 12, and is that the same thing as, 5 over 12.5, is that the same thing as 8 over 20? So I wrote those as equal. Let's make sure they actually are. 6 over 15, so we could divide top and bottom by 3, and so that would give me 3 fifths. So 3 fifths is that fraction. That's as reduced as we're going to get. So let's see, 2 fifths, divide by 3, 2 fifths. Because then over here, this is one's not so bad. 2 fifths, we can divide those by 4, and we get 2 fifths as well. 5 over 12.5, not as easy. We could double it and get 10, 20, 20 fifths and then reduce. But you can also just do these by typing them in. 6 over 15 is that, which you could turn into a fraction, 2 fifths. We could do 5 over 12.5 and get the 0.4. We could just leave it as the 0.4. We know it's the same, and 8 over 20 and get 0.4 all 3 times. And that shows that those are all proportional. So then they are similar, and the triangles that are similar are, we could write it a few different ways. I'll do triangle PQR is similar to triangle, and so PQ correspond to like ST, and then QR goes with that, so it's going to be STR. Make sure you get those corresponding parts lined up, the parts that are proportional or the angles that are congruent. Over here, we have some sides to work with. We also have an angle, so we've got this shared angle that both triangles share. There's this bigger triangle and then that smaller inside triangle. So we've got an included angle, and so if we can just show these sides are proportional. I'm going to go small triangle to big triangle, so 10 over the full length of AB is 15. That would be the corresponding side. It's 10 to 15 is that full length. And then over here it's going to be 8 to 12. Is 10 over 15 the same thing as 8 over 12? You can bust out the calculator, but we can divide both those by 5 and get that that's divide by 5, we get 2/3. Divide by 4, we get 2/3. So they are proportional. Sides are proportional. Angle A is congruent to angle A, obviously reflexive. And so therefore we know those triangles are similar. So we could say triangle AFE is similar to triangle ABC. All right, and then properties of similarity. So these are kind of similar to other properties of equality and congruence. So the reflexive property of similarity, ABC, is going to be similar to itself, triangle ABC. The symmetric property, if ABC is similar to DEF, then we know DEF is going to be similar to ABC. And then the more interesting one of those is the transitive property. If ABC is similar to DEF, that means that ABC has the same angle, like those angle measures match DE and F. And then DEF is similar to XYZ, which means that D is the same measure angle as X and E is to Y and so on. Then we know that ABC is similar to XYZ. We can do the transitive property of similarity. All right, and then using some of those properties, we're going to find BE, which is just X. They want us to solve for X, and AD, this full length, which is going to involve figuring out what Y is in there. So we know that these triangles are similar. Maybe it states it in the problem, but also here we can see, for instance, like this angle is the same, and then these are parallel lines, so those angles would be the same because they're corresponding. So that's enough, just those two angles alone, to know that this small triangle is similar to that bigger triangle. We want to use our reference point. A lot of times these problems will have at least one side where it's like we actually have the numbers. So AB, the small triangle over big triangle. So AB, I guess I wanted to write out what the actual number is. So that is 3 over the full length is 5. So this ratio here is 3 to 5 from the small triangle to the big triangle. And so that's like our scale factor. So we're going to use that though to understand the rest of this. So for instance, x, if this is this triangle's 3/5, that triangle, x would be 3/5 of, match that same fraction of 3.5. And so that's going to be in that same ratio. And we can just cross multiply and solve. We're going to get 5x is equal to 3 times 3.5, 10.5, divide by 5, and x is 2.1. So that's x, and that's also what BE is. So BE, final answer, 2.1, and we don't have units. So that's one of my two answers. The other answer, AD, we need to figure out what y is. So we can set up a similar ratio, and I'm actually going to use the same 3/5. So 3/5 should equal y over, and this is the trick here, what is that full length? From A to D, that's actually going to be y plus 3. So y over y plus 3. That looks a bit uglier, and it is. But we can still solve it with some cross multiplication, get everything out of the denominator. So we're going to have 5y equals 3 times y plus 3, which we can then distribute and get 3y plus 9 is equal to 5y. Subtract 3y off of both sides, and we're left with 2y equals 9. Divide both sides by 2, and we get y is 4.5. Not the answer, though. I want to know what AD is. Well, if this is 4.5, add on 3 more. AD is 4.5 plus 3, which is 7.5. And so that is our other answer to this one. Finally, another classic type of problem. Hallie is estimating the height of the Superman roller coaster in Mitchellville, Maryland. She is 5 feet 3 inches tall, so 5.25, got it into feet, and her shadow is 3 feet long. If the length of the shadow of the roller coaster is 40 feet, how tall is the roller coaster? So we've got this included angle here, or I guess with those sides, but I guess the other important piece, we've got that they're both right angles since we're just measuring height. But the other important thing is that shadows, they come from this fixed point far away. So this angle is the same as that angle, right? And like this angle is the same as that angle. The angle of inclination to the sun and or down. So we have similar triangles, though the lines here are parallel. So with that, we can set up some ratios. So we could set up 5.25 over 3. Her height to shadow length ratio is going to match the roller coasters, and I'll call it x over 40, right? The 40-foot shadow. So we can then cross multiply and solve. 3x is equal to 5.25 times 40. Let's make sure we get this right. 5.25 times 40 is 210 equals 3x. Divide by 3, and x is 70. And so the roller coaster is 70 feet tall.